Okay? Here's the deal. Your score is in Canvas. Okay? We're not going to go over this in class because obviously Milton has to take it still, so it's not a good idea to go over it when he hasn't taken it, right? So, when he's done taking it, if he has any questions, I can answer those then. I'm going to give, I tried to number how many points you got on each question. And I tried to, and I'll give the key to Kaylee and Brooke, and they'll be able to tell you, hey, that's the one you missed. Obviously, like the first 5 questions were like 5 points, and it tells you, actually no, it tells you, I did that right. Yeah. So each it tells you what each question's worth on the exam. If you didn't get that number, then you missed that question to a portion, right? I gave you partial credit for a lot of questions. So like the proof, I think everyone, if they tried, you at least got 2 points, is how I did it. So if you at least tried, you got 2 points out of 10. If a lot of people, 6 was probably the average score on the proof. Some people got 10, some people got 6, some people got 4. So that was that. But overall, the test was very good. Like you guys did very well. Like I was a little shocked. So like in a good way.
Yeah, you're shocked that you're such a good teacher.
Well, I'm shocked that you guys did so well. So good job to you. Pat on the back. Huh? Oh, thanks. Yes.
So would you say that the average of the class was about 70?
Yes. There, you know, some of you, if you scored below a 70, this is what you got to do. Listen carefully, because the first years are screwing this up a little bit, and I had to re-explain. So, if you score below a 70, you've got to do corrections on every question you missed. Not the ones you want to do, just every question you missed. Then I bump you up to a 70% for the test. All right?
Yeah, Mr. Robson.
Let me finish. When you do the corrections, okay, and Kaylee and Brooke will look at this, when you do the corrections, you do as they ask, number 1. Okay? Number 2, you need to give me an explanation on why your answer was wrong and the one you chose is right. And it has to be a mathematical, algebraic structure explanation, not just because, oh, I didn't study. Oh, because it's actually sometimes and not never. Why is it sometimes? Why is it not never? Like on these questions, there's never, sometimes, and always. Okay, if you selected sometimes and it's really always, well, tell me why it's always and not sometimes. Give me a good reason. Okay, the best reason you can come up with. I don't know, and that's a good guess. Or my buddy told me it's always. Okay, don't give me a garbage reason. Give me a good, sound reason. So, for example, X is an element of A intersect B implies X is an element of A or X is an element of B. Well, if X is in A intersect B, it's got to be in A and it's got to be in B. So that's always going to be true. Okay? Always. Yes?
So let's say like we got above a 70%, but like we still missed like a problem or two, but if we want to correct them, can we do that? Or
No. Because the reason being, prep, we're looking at you to make sure you guys get up to a 70%. So if you guys all get up to 70%, then it's just pass or fail. Does that make sense?
Yeah.
So this is the game where the percentage doesn't matter, unless you're below 70. Does that make sense? So, yes.
So, on the midterms, did all the points add up to 100?
Yep.
Okay.
Yep. So I got it out of 100, so it's easy to calculate. Okay? So I'll give these to Kaylee and Brooke. You can look at them in study hall tomorrow. Millie, you'll be here tomorrow, right?
Yeah.
You'll take yours in study hall tomorrow.
Right.
Okay?
Milton.
And we won't talk to anyone while he takes it. Okay, Kaylee? Make sure he's not talking to anyone when he takes it.
So he isn't a idiot. He doesn't talk much.
No talking period. And here's what I did also. Day 9 quiz was the other thing that I had still. This is day 9 quiz. Okay? So, the nice thing about day 9 quiz is it's got a paragraph proof, is what it was. It's a paragraph proof, right? The test has a paragraph proof. So I can see that kind of where you were on the paragraph proof. Okay? And you guys did better on the paragraph proof here than did here, so it's worth my time to just take this one and look at it. So I erased the day 9 quiz from Canvas. So it's not there. So it doesn't hurt you, doesn't help you, okay? Not there. Yes?
What if you, didn't take the day 9 quiz?
Then that's a
and
freebie.
didn't answer the proof question?
And I still know where you're at on the proof question. Okay? Bueno? That means good. But the few Spanish words I know, that's all. And queso. I know queso. Cheese is so good. I love cheese.
Good and cheese.
Yep, good cheese. Good cheese is sharp cheddar cheese. You guys like sharp cheddar?
Yes, that is
I
the
love
best
sharp
cheese.
cheddar. So, I make this macaroni and cheese. You guys know what Instant Pot is? Okay, Instant Pot mac and cheese is the best.
Alright.
Yes.
I'll look at the recipe.
Yeah, I've got a recipe from the Salty Marshmallow. It's a website, and it's really good.
That's
The
not just,
salty marshmallow.
that's not just the
Yes,
macaroni
that is
work
what
here, your
your
website,
website
right?
No, this is real mac and cheese.
It
Like,
should have been the tea.
so in the Instant Pot, this is what you do. Let me tell you guys my mac and cheese story.
Marshmallow.
Hey, I'm gonna tell you how to make mac and cheese.
Let's just talk about mac
Oh, I'm
and cheese.
opening this.
This is important.
This is very important.
Right?
Yes.
Hey, get it out of a piece of paper quietly while I tell you about mac and cheese. So, mac and cheese, you put the noodles in the Instant Pot. You turn the Instant Pot on for 5 minutes for high pressure. And then, once the Instant Pot is, you don't put them in water, you put them in chicken broth too. And then, the noodles are all cooked when you open it up, you dump all the cheese in, you mix it up, and you eat it. It's great.
That's fast.
Yep.
That's faster than
So if you weren't listening, you missed it.
Have you tried adding
Try and cook minute noodles in
Hey,
30
you need to
seconds.
you need a blank piece of paper and then close your books. We're gonna take a quiz.
What?
I need to study this first.
Blank piece of paper,
They open.
blank piece of paper.
And this is stable, not like
Day 12 quiz. You cannot use notes. This is a closed book quiz.
Wait, we did not?
No notes, no notes. So, to review, if I'm using a 7 o'clock, okay? Since I'm a picture guy, I'm gonna draw a picture. Do you have to draw a picture? No. Okay, if I use a 7 o'clock, this is what I do. Your quiz is not using 7 o'clock, so I could care less that we show this to you. So if I show you the clock, you tell, depending on what kind of clock you're using, we're using 7 o'clock. 7 o'clock, 7. Okay, what is 4 plus 5? 4 plus 5, what do you got? 2. So 4 plus 1, 2, 3, 4, 5 is 2. Good. Okay, 4 minus 7. 4 minus 7, what do you got? 4 because 7 acts as 0. Good. Okay, let's do one more. 2 plus 10.
5.
2 plus 10, so that'd be 1, 2, 3,
Yeah, 5.
4, 5, 6, 7, 8, 9. Did I count that wrong? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yes, that would be 5. Okay, another way to think about it. If I have 2 plus 10 is really 12, yes? Okay, in our normal number system. 12 minus 7 is really 5. So you take that 7 out. Take 7 out as many times as you can until you get to a number that's in our 7 o'clock. So, for instance, if you had 21 plus, let's say, 14. 21 plus 14 is really what? 35, right? Yes?
Yeah.
So you're going to take out, you're going to do 35, take out 7, 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 okay? But what's 35 really in 7 o'clock? What is it? Uh-huh. Okay, so let's think about this. 21 would be 3 times around, basically, yes?
Yeah.
And you'd land on 7, yes?
Yes.
Plus 14 more. Land on 7, yes? Okay. Yes, 5 does go into 35 and you get 7, but that's not how it works. You're saying, how many times can I take out 7? And then what do I land on after I take out those values? So it's not how many times necessarily, it's like what do you land on after you take out the max amount of 7s? Well, in this case, I land on 7. Okay? So So how many do you have to take out? In this case, we would take out 6 of them, and that would be 7.
What?
35 minus 7, 7, 7, 7. Oh, sorry, we take out 4 of them, sorry. Take out 4 of them. And then we would land on 7. So we're not gonna take out 7 more to get 0, because 0 doesn't exist.
Well, also,
But if we did take out 1 more, we'd land on 0, which would still be 7.
it's okay, it's divisible by some of you should know that.
Yes.
One thing I figured out for addition, for division is if it's above the number in the sum pot, you can just get the answer. And then, you know, if it's above the answer, you just use the addition, tactic to just find what it would be for the top.
Yeah, we looked at like a couple different ways for division last time, right? Think about it. That's kind of one of them, is how division would work.
Yeah.
But we're really doing addition, but we are doing division too at the same time. Sort of. Okay, questions? Calvin, did that help seeing that for a second?
Yes, it's just reading through this.
Okay, so we're gonna project this on the board, okay? Don't look at your neighbors, that's called cheating, okay?
I like,
Cheating is not good
Cheating
for
is
you.
a no-no.
Yeah, it's a no-no.
Mr. Robinson just like Nash, get out.
Don't be a no-no kid.
Here's the thing, if you're well-disciplined and prepared, you don't have to worry about cheating because you know what you're doing. Kind of a simple concept, which, you know, a lot of the world forget, we have a better world.
Jack?
Okay, I'm gonna open this. Make sure your notes are closed, okay? I just want a piece of paper out, please. So you're gonna turn this into Kaylee and Brooke. And we don't want the little frillies on the edge of the paper either, okay?
Wow.
Like when you tear the paper out, it's got all the little pieces. Yeah, make sure those are off.
How come?
You want a nice, clean cut piece of paper with your name on it. Put your name on it right now. You didn't do it already. Put your name on it. Yes.
Is all this from statistics and probability?
This stuff?
Yeah.
No, this is from some people that were studying in here earlier.
What were they studying for?
Looks like engineering or physics of some sort. I don't know.
Could be a foreign language.
It could be,
No, it's
English.
Oh, I need to turn on the projector. That's a good idea.
Okay, answer all the questions, even though you don't know if they are.
Yeah, I'm trying to get there. It's not very nice.
I'm ready to win at this test. That's how it works, right?
This is the day 12 quiz, right?
Don't you?
Day 12 quiz.
So it's not.
Okay, you're gonna do addition, multiplication. You guys listening?
Yeah.
Okay, on a 5 clock.
So we're doing
Addition, multiplication, subtraction on a 5 clock.
Oh, we're not doing it on 9 o'clock?
Yeah, that says 9 o'clock.
I don't know. I need a piece of paper.
Says none.
Oh, I was reading the wrong thing. Yes, 9 o'clock. Ready to go.
And no division.
Keep your eyes on your own paper.
Do you want us to just write the answers for the question?
Yeah, show as much work as possible.
Well, like, rewrite it for.
Yes, you need to show me distinctly what 4 plus 8 is. And it's not 12. You should make sure you guys label this nicely. Number 1, 4 plus 8 equals blank. Number 2, 8 plus 9 equals blank. Kaylee and Brooke don't want to search for it. Okay? If they have to search too hard, they mark it wrong. Calvin, you want to take it
Yeah.
tomorrow again, or you try to take it now?
I'm gonna take it now. I just need to get my paper.
You actually missed the best possible day you could probably miss.
Yeah, I just realized that after reading through it for a little bit.
You always read through. You've got a calendar. Yes, ma'am.
Oh yeah, the arithmetic one is actually pretty easy.
Go. You guys have 2 more minutes left.
What?
Quick.
I'm gonna need more than 10 minutes to move on.
Stop talking.
Is that a, is that a division?
There's no division.
So I need to share the workbook with you guys, the instructors manual, right? Okay. And then you guys should grade this. Just 10 points, just 1 point question. Yeah, it's just all of it. So then just throw in cameras. I promise that's what you're gonna do.
Only numbers exist in the
Is there only a reason?
Hey, flip your paper upside down when you're done.
I'm not done still.
When you're done, flip it upside down.
Oh, when you're done.
Don't talk. Think about it. Just do this. Alright, you need to finish up the one you're on.
Yeah. What's the subject today?
More clock stuff? No, we'll do that. Just keep it in here. Have everyone's? Huh? Yes.
Out of the three classes that you teach, which one do you think is like the most difficult?
Either this or logic.
Logic is weird.
This one is, next week is hard.
What you define as hard or what we define as hard?
Both.
Oh,
First thing the proofs.
No, I would rather, next week is, it's proofs, but it's not like the same kind of proving. Like, it's not gonna be big, long, ugly ones, like some of our part one and part twos, we're not proving set theory. We're looking to see, it's not, I wouldn't say prove, maybe, we're gonna be looking at groups is what it's called. And those are like foundational to algebra. Why we have algebra, basically, why algebra works, essentially, when it comes down to it. Today is not terribly difficult. Next week is more difficult, though, I would say. Yes.
So, question arose in problem solving, and the white bear told
One second.
me to ask,
I shared the instructions now with both of you, so you guys can get this.
so, and the white bear told me to ask you the question. So the question is one prime?
Is one prime? I've heard this question. I think it depends, if I remember right. Your dad would definitely know the answer, I know that. There's a proof to it.
no proofs.
There is a proof to it, though. I can't remember where I heard this question. Was it in college? Or like my first couple years teaching, we looked at the proof for it. I can't remember what we looked at, though. What's the answer? Does he have an answer?
No, you didn't. Some people think that maybe prime.
Theoretically, it's also not different.
So, out of the math community, I think this might be a debate because, like, some people say one is prime because there's like two different definitions of prime. Because there's one that's one in itself, and there's another one.
Right, one in itself.
Just let him finish.
And there's another one, and there's only two factors, one in itself. So here's the thing, one in itself, there could be just one factor. But with only two, one has only one factor. So it doesn't fit one definition, it does fit another.
So it depends on what definition.
Yeah.
Actually, I don't remember the exact answers to that. So, yeah, I think that sounds like what I remember. We can just talk about that. Day 13. Here we go. Fun. Oh, we started talking about this. That's what we did.
First page.
We talked about closed and not closed. Okay? to refresh your minds a little bit. Okay? N, the natural numbers, okay? So we're taking stuff in the beginning of June, okay, our number systems, our number types, I guess, our real number system, and we're saying, are the natural numbers closed? Now, what we did talk about with closure, okay, the set S is closed, so any set, S could be any set. Any set is closed under the operator. Remember, this sign is operator, it's not multiplication. If for every x, y is an element of S, and x operates y is an element of S. So if our operation is sum, difference, product, quotient, we showed last time that n is closed under multiplication, it's not closed under subtraction because we go into negative numbers, and it's not closed under division because we can get instances where we don't have a natural number as our result. So with this we talked about last time. Okay, does everyone remember? Yes?
Can I go to the bathroom?
Probably not a good time to go, but if you want, yes.
I can do it.
So, then we talked about identity and inverses. Okay, inverses, okay, if we look at the multiplicative inverse, so if I have x times 1 over x, I get 1. Additive inverse, we get 0. Additive identity for here, whatever we can add to x to get out x. So in these numbers, it's, in this case, we add 0. That's our identity element. Our multiplicative identity, it says whatever we can multiply by x to get x. Identity. Multiply by something to get the same thing out, or the first value out. So we talked about how you guys need to understand this when you guys left on Thursday. Okay, going on. This, hopefully you guys did go look at that. So if x equals 4, I'll just put right. Okay, if x equals 4, then 4 plus 0 is 4. That's good. Okay, 4 plus a negative 4 is 0. 4 times 1 is 4. 4 times a fourth is 1. Okay? What do each of those statements mean? What's going on? What's 4 plus 0? What's that representing from our previous page? Yes?
The identity of addition.
Okay? Additive property of identity. So identity property for addition. Okay, we come back up here. Additive identity. 0. Okay, good. Okay, the next one. What's 4 plus negative 4 representing? 4 plus negative 4. Yes?
The additive inverse.
Additive inverse. You're adding its inverse. It's opposite. Okay? 4 times 1. What's it representing? What's 4 times 1 representing, Milton?
Wait, hold on. Is it the multiplicative in identity for
Spot on. Okay, 4 times a fourth. 4 times a fourth. What do you got?
Multiplicative inverse.
Multiplicative inverse. Okay? Multiplicative inverse. Now think about this. If you're multiplying by a fourth, multiplying by a fourth, that's the same as dividing by a fourth, right?
Yeah.
Is it not? 4 times a fourth is the same as dividing by a fourth. Whatever you have to divide by or multiply by, okay, in this case, multiply by to get 1. Okay? But I like to think about it divide because if I remember, oh yeah, that's the inverse of multiplying, so I'm going to divide by 4. It helps my little brain make more sense. So if it doesn't help you, then don't think about it that way. Note, example 2, consider n, then the following is true. So n is what we're considering. What does it mean to consider n? What does it mean to consider n, Jonas?
Is it like it could be true or no? You're saying it is true?
We're saying we're looking at n. N is our world right now. Okay, we don't care about anything else but n. What's n mean? What's n mean? Yes?
Natural numbers.
Natural numbers. Okay, consider n. So we're going to look at n. We don't care about anything else, we only care about n. So that's numbers 1, 2, 3, 4, all the way to infinity. All the whole numbers from 1 to infinity. Right? But it doesn't include 0. Since 0 is not an element of n does not contain an additive identity. Think about it. I can't take any number in n and add another number to it to get out the original number. So I can't say 1 plus some number equals 1 in the natural numbers. It's not going to happen. It cannot happen in the natural numbers because that number usually is 0. 0 is not an element of n. As a result, no element of n has an additive inverse. The multiplicative identity of n is 1. However, except for 1, no element of n has a multiplicative inverse. Why? Why? Again, the multiplicative identity of n is 1. That means any number in n times 1 gets you out that number. So, 4 is an element of n times 1 gets me 4. Okay? But the multiplicative inverse does not happen in n. Why? Why do we not have a multiplicative inverse?
Because the multiplicative inverse must be a rational number because it's doing a fraction.
Exactly. And does n have fractions? Or, I wouldn't say that. Does n have rational number? No, let's say that word. A traditional fraction of where the fraction can't be equal to a natural number. So meaning, you've got to have some number that's not whole, right? So n doesn't have that option. N is just whole numbers except 0. So you can't do, in other words, if I take a value of n, 5 is in n, right? It's an element of n. But its multiplicative inverse is going to be 1/5. You can't do numbers like 1/5. Both of these values have to be in n. And they're not in n. So, yes? No.
Basically, you just can't divide.
Uh, We don't have an additive identity, and we don't have a multiplicative inverse.
This seems like a paragraph.
You don't want to look at it necessarily as divide. I would say I would think of it this way: that you can't have these things happen. So if you go back up to the page previous, those four, you got multiplicative identity, multiplicative inverse, additive identity. The multiplicative inverse doesn't happen here, and the additive identity can't happen here.
Right. So that makes sense, but you couldn't do 45 by 4 because you can't do division because that's a fraction.
Well, 4 divided by 4 would give you 1. That's okay. Because 1 is in, but we're looking at identities and inverses, so it's a little bit of a different concept, I feel like. We're not saying you can't divide necessarily. I'll have to think about it more, but I wouldn't look at it that way quite yet. I would keep it more of just, oh, I can't find multiplicative inverse. If that means, oh yeah, I can't divide by something to get their 1, then that's fine. But be careful how you think about it, is what I should caution you on for what we're going for next. But good reasoning, yes. Who had their hand up over here? Okay. Note, in a particular set of numbers, like n, the existence of an additive identity is necessary for the existence of additive inverses. However, the existence of an additive identity does not guarantee, does not guarantee the existence of an additive inverse. A similar statement can be made with regard to multiplication. That's what we just saw with n. Okay? So, highlight this little thing. So this is a true statement. The existence of an additive identity is necessary for the existence of additive inverses. It's necessary. But identity does not guarantee inverses. Okay? Identity is necessary for inverse, but it does not guarantee.
But then if it's necessary for it.
It's kind of like the word or. It means things differently.
Right.
We're saying we can't have an additive inverse if there's no additive identity.
Right.
But we're not saying we're going to have an additive inverse if we have an identity.
Oh, okay.
Does that make sense? It's necessary if we're going to have an inverse. So, maybe this answers your question too, Calvin. Here's the rest of it. It says, in other words, the existence of an additive identity is necessary but not sufficient for the existence of additive inverses. And same thing with multiplication. We're going to skip the optional example for just a minute. We'll try to get through it real quick. We got 2:36, we got 20 minutes, okay. So, optional example. So if we look at the 5 o'clock here. Okay, we got our table. What kind of table is this? An addition, multiplication, what? Addition. So we're going to take this 5 o'clock, this clock arithmetic idea, and apply it to what we just looked at with inverses and identities and with closure. So the 3 new concepts for day 13 are closure, inverses, and identities. Okay? We're going to take that and put it with our clock arithmetic, and we're going to carry on with those ideas going forward. Okay? These are all foundational ideas to what we're going to do the rest of this week and next week. So these, again, foundation. It's good to have a good foundation, right? If your house has a bad foundation, what happens? Your house falls apart, okay? I got some friends, their house is falling apart because they have a bad foundation.
Really?
Yeah, seriously. They live in that town. But, so they have a bad foundation, the house is falling apart. It's kind of like, you guys see that building collapse in Florida?
Yeah, that was cool.
Yeah, it was not cool. People got hurt, died.
Well, the video was cool.
Bad foundation, right?
Well, that was more because of a sinkhole, not a bad foundation,
Most of
wasn't
the
it?
sinkhole is part of the underneath foundation, roots foundation. Foundation goes everything. So, I did. We got foundational stuff we're going to keep using. So, 5 o'clock. Okay, this is what happens in a 5 o'clock. This is our additive table. So, the additive identity is 5, meaning 1 plus 5 gives us 1. 2 plus 5 gives us 2. Because 5 acts as 0. Okay? Each element, okay, 1 plus 4 is 5. This is where it gets tricky, okay? 1 inverse is 4. See the little -1 here? You guys see the negative ones?
Yeah.
I need everyone to look at the negative ones. Everyone look at the negative ones on your paper. That means inverse. That's not an exponent of -1. It means inverse in
So
this
it's the
class.
opposite of an exponent?
So, 1 plus 4 is 5, yes?
Yeah.
So the inverse of 1 is 4.
Oh.
2 plus 3 is 5. The inverse of 2 is 3. Okay, the inverse of 2 is 3. Okay, now why is this working the way it is? Now if we think about inverses, what do inverses do in a normal number system, like in our real number system? What's an inverse get us to? What's an inverse get us to?
0.
Gets us to 0. 5 acts as 0. So the number that gets us to 5 in a 5 o'clock is the inverse for that number. So 3 plus 2 is 5. The inverse of 3 is therefore 2. Okay? 4 plus 1 is 5. The inverse of 4 is 1. But the inverse of 1 is 4. So see how it kind of switches up a little bit? 5 plus 5 is 5. That is, the inverse of 5 is 5. So what do you got to add to the number to get 0? Which we don't have 0 in this particular case. Okay, 0 doesn't exist in a 5 o'clock. So we got to take this abstract idea and now we're going to make it more abstract. Okay? Continuing with identity now with inverses, okay, identity is different than inverse. Okay? Inverse gets us back to 0, yes? Okay? Identity gets us back to what we started with. So in a 5 o'clock, again 5 o'clock, 1 times 1 is 1. 2 times 1 gives us 2. 3 times 1 gives us 3. 4 times 1 gives us 4. 5 times 1 gives us 5. That's nice, that's friendly. But a multiplicative inverse, it's a little different. When we get a multiplicative inverse, so go back to a real number system, multiplicative inverse in a real number system gets us to what? So again, if I was back up, go to the previous page, if I had 4 times 1/4, what do I get? Multiplicative inverse, right? Multiplying its inverse. Multiplying an inverse. So that got us 1. In a 5 o'clock, we're still going to look at this. 1 times 1 is 1, yes? 2 times 3 is 1.
So multiplying the opposite will always give you a 1.
Wait a second, okay? 1 times 1 is 1. 2 times 3 is 1. 3 times 2 is 1. 4 times 4 is 1. Okay? If I do 2 times 3 in a 5 o'clock, what's 2 times 3 in 5 o'clock? What's 2 times 3 originally? Let's do that. 6, which is 1 in a 5 o'clock. So, if I take a multiplicative inverse, it's what do I take the first number, what do I have to multiply the first number by to get 1? What do I have to multiply the first number by to get 1? So we're still getting 1, because 1 exists in our 5 o'clock. Now, 1 inverse is 1, because I multiplied by 1. 2 inverse is 3, because that's what I multiplied 2 by to get 1. 3 inverse is 2, because 3 times 2 is 1. Do we see it? We filled this page and the bottom of the page previous. This is the goal page. Okay, this is the page you want to start and say, okay, this is where I need to go to remember, hey, this is how inverses and identities work in different clocks. We're working with different clocks, different numbers systems. So, now we're going to combine our number system with clock arithmetic. So, we consider a 5 clock if whole numbers are part of the 5 clock. And this is what happens. In a 5 clock, 5 behaves as a 0. Okay? But if we say 5 o'clock in the whole numbers, what that does, so we were basically doing 5 o'clock in the natural numbers before. Okay? That's what we've been doing since last Thursday, is 5 o'clock with natural numbers. We've been working with natural numbers. But now we're saying, well, what if we take our clock arithmetic and apply it to whole numbers? If we apply it to whole numbers, okay, we replace the 5 with a 0. That is, 5 o'clock is now 0, 1, 2, 3, 4. There is no 5 in 5 o'clock. Okay? There is no 5 in 5 o'clock if 5 is part of the whole numbers. Okay? So 5 o'clock in W, 5 o'clock in the whole numbers is 0 through 4. 5 o'clock in the natural numbers is 1 through 5. Good?
Yep.
So that changes things a little bit. We have 0 now. So now let's look at our new addition table. So our addition table is 0, 1, 2, 3, 4 as shown here. Okay? 1 plus 0, 1 plus 0 is 1. 2 plus 0 is 2, 3 plus 0 is 3, 4 plus 0 is 4, 0 plus 0 is 0. Good. What do we have to add to get back to what we start with, the identity? What do we have to add to our first number to get our first number?
0.
Okay? So in this case we had 0 all. Now the additive inverse is a little different. 1 plus 4 gets us back to 0. 2 plus 3 gets us back to 0. Not 5. These were 5s before, right? But it's really the same thing. We're just replacing 5 with 0. Or replacing, taking the 5 out, putting 0 in, right? So it's kind of the same thing as before, except for the zeros change. 3 plus 2 is 5, which is 0, which is the inverse of 3. 3 inverse is 2. So that's what we have to add to 3 to get 0. 3 plus 2 is 0. You can go home and tell everyone today 3 plus 2 is 0. You can tell everyone today 4 plus 1 is 0. You can tell everyone at home today 2 plus 3 is 0. You blow their minds. Right? It's kind of fun. Okay, questions? Okay, additive inverse. What do we have to add to the first number to get 0? Additive identity. What do we have to add to the first number to get the first number? And the idea, the most confusion with this will come between, okay, which one's which? Which one's identity, which one's inverse? Okay? Additive, inverse, and identity. Yes?
So up there on the multiplicative inverse, it always for the inverse of like the 5 or like sometimes 10, does that always not exist?
So the question would be, why does 5 inverse not exist?
Would it be because you can't multiply, because it would always go back to 5?
So here we're trying to get, so on this one, this is 5 o'clock and natural numbers. 4 times 4 gives us 1. That's really 16, yes? 4 times 4 is 16. 5 goes in there and you have 1 left over. That's your remainder. Okay? 3 times 2 is 6. Remainder is 1. Okay? 2 times 3 is 6. Remainder is 1. Now, can I take 5 times a number and get a remainder of 1 essentially in a 5 o'clock? No, because 5 times any number will be a multiple of 5, so there wouldn't be any remainder when you divide it out. That's in a natural number though. That's a natural number 5 o'clock. Let's see what it looks like in a whole number 5 o'clock. Okay, let's see if your idea sticks here. So if this is our whole number 5 o'clock for a multiplication table, does that idea hold? It looks like it does. Yes?
So, if you were doing like instead of 5 o'clock, like a 4 o'clock, for that multiplicative inverse, when you did like 2 times whatever, would that have to be a decimal? In order to get 1?
I would have to actually go look at it. I can't visualize it very well like that. I have to look at it. So coming back to this idea real quick. Okay, multiplicative identity. Whenever we multiply for an identity, we're trying to get what I multiply the first number by to get the first number. Well, 1 times 1 is 1, 2 times 1 is 2. Good, okay, that one's good. Multiplicative inverse, though, a little different. 1 times 1 is 1. 2 times 3 is 1, because 2 times 3 is 6. We're in a 5 o'clock, right? So again, we think about it, instead of having that 5 be a 5, 5 is really 0. Okay, 3 times 2 is 1, 4 times 4 is 1. So the inverse of 1 is 1, inverse of 2 is 3, inverse of 3 is 2, so on. Now, can I take 0 times a number and get 1? In a 5 o'clock. Because if I take 0 times 0, that's just 0 again. 0 times 5 would be back to 0 again. 0 times, it's just going to bring you back, no matter what. Okay? Questions? I can't give one of that. Okay. Now for your assignment. Okay? For the next week and a half, so this week and next, your assignments, listen closely, your assignments are significantly harder than the quizzes. The quizzes are a lot easier. The quizzes are a lot shorter, because the quizzes have to be done in like 5 minutes, right? The assignments take some time, and they're going to make you think a little deeper. For this particular assignment, let's look through what you have to do before you go and start it. Let's talk about it. Okay, for an 8 o'clock, construct both an addition and multiplication table. Use those tables to determine the identity element for each operation, then find the additive and multiplicative inverse for each element in an 8 o'clock. So an 8 o'clock,
Thursday's homework.
we did it in class. You guys did it in class.
No, yeah, I thought we did that and we did the next lesson.
We started this lesson. We didn't finish it. This is a little different.
I know, I already.
So this is 8 o'clock in whole numbers. So we got 0, 1, 2, 3, 4, 5, 6, 7. 10 o'clock, construct both an addition and multiplication table. Use those to an identity for each operation, then find the additive and multiplicative inverse of each element in 10 o'clock. 10 o'clock is this. I want you to do number 1 or number 2. Okay?
Math or normal or?
Don't.
I already did both.
If you did both, be great. Make sure you've answered the question though, because we didn't talk about inverses and identities until today. That's the key, is you need to do, if you guys look at example 3, notice it says refer to example 3. Your answer should look like example 3. I should see the identities written out. I should see the inverses written out for both addition and multiplication. Now, if we look at the tables though, where do you see, okay, let's look at this. Look at the table. How can you find the identities and the inverses using the table, looking at the patterns? Is there a way to see that? Is there a way to see that? So look, what do you got, Jones?
If it's like on the addition adds up to 0, I think, then like for 1 plus 4, then you know like it's that's still added with the inverse for 1 is 4.
So can you show me what you mean? Can you come over here and show me? And point at it. So this is our additive or addition table.
So 1 plus 4 is 0. So now the inverse of 1 would be 4 because they have 0 is 0.
Okay.
And
Okay, other patterns you guys are seeing with the identities and inverses on here. Yes, Melody?
You just basically shifting down a number every time, right?
Say it loud for me.
You just basically shifting down a number every time, right?
So here it's 0, 1, 2, 3, 4. The 1 goes up, and 0 goes down.
Yeah.
Okay? The 2 now comes up, comes down. So your table shouldn't be too hard to make if you're following the pattern. These are patterns. The patterns are going to happen every time. Okay?
So we should be able to see the pattern after like 2 rows. Do you think?
Probably. Or 2 columns, depending on how you're thinking about it. Yes, reckon. Huh? Yeah. So, again, on your assignment, so each question, now listen, each question requires 2 tables. An addition table and a multiplication table. I need identities and inverses for each. I don't care which question you do, just pick one. Okay? If you did both, great. It's probably a wise idea to do both. You do have a quiz tomorrow. For the quiz, what you're going to have to do, and I'm going to tell you what you have to do on the quiz. You might want to listen, those of you that are working and all you work. What you got to do on the quiz is more, you're going to have to do some subtraction and multiplication and addition and division. So division is going to come into play tomorrow. We did talk about division last time a little bit. You have 2 division problems. Then, also for tomorrow, you need to be able to determine a multiplicative inverse of given numbers in a certain clock. Okay? So you have to find 4 inverses tomorrow. Okay? Any questions concerning the quiz? Yes?
So how do you try to, like, don't you just look at the multiplication table?
Essentially, yes.
Okay,
Just think about this. If you have a multiplication table, you just do the inverse, yes?
yeah, so you do. Okay.
I'm going to go back to an example real quick. Okay, a review on division for tomorrow. If you want to watch, you can. If not, then do your assignment. Okay? For example, I want to find, this is a 7 clock in the natural numbers, okay? Whole numbers works the same way. You just got to be careful which number you're using, because in whole numbers, it's 0, 1, 2, 3, all the way to the number, okay? So, this is 7 clock with the natural numbers. 6 divided by 2 is 3. Okay? 2 times 3, though, is really 6, yes? Okay, yes. 6 divided by 3 is 2, 6 divided by 4 is 5. Now, this one's a little harder, right? We're thinking, oh, it's a decimal, it's a decimal. No, it's not. Okay? 6 divided by 4 is 5. How do we logically think about that with our table, and how can we use 6 divided by 4 here to get 5? Any ideas? Yes?
So you find like the numbers, like if it was 4, you do, and then you can go over or up, and you can do,
Am I looking at the 6 or the 4?
the 4.
So the 4. Okay, where's the 4? Here? Like this one?
No, one in like the middle of the table.
4 here?
4
4 here?
the one, yeah, the 4 and the 6.
4 in the 6th column. Okay, 4.
Yeah, and then you can go to the side and you get 4 you go 6 divided by 4 and then you get 3.
But 6 divided by 4 is 5. That'd be our problem. Yes?
So what you do is whatever like the dividend is,
What's the dividend?
6.
Which is what?
Like what's getting divided.
Dividend and divisor, okay? So, dividend, divisor. And this is called the quotient, yes? Sorry, I should have wrote that down here. So, dividend, divisor, quotient. So, in a division problem, you got to know those words. You got to think about it this way. Okay, what do you do with dividend first?
So then, Well, so with your divisor, you would find that on either the top or the side, so you
Okay.
find 4.
So I can find 4 here on the row, here on the column.
Yeah.
Okay?
And then you find your dividends in that column or row.
So 6 here or 6 here? Yes?
Yeah.
6 divided by 4 is 5. Okay? So it's very, very important you know how to make a table to understand the division a little clearly. Okay? Dividend 6 divided by 4 is 5 here. So it doesn't matter if you look at the column first or the row first, as long as you're if you're looking in the 4 row, okay, 4 row, so you can do dividend divided by row, which is 4 row, gives you column 5. Or you can do dividend divided by column, gives you 5 row. Okay? No, that's just another way to think about it. Yes, Melody?
Would you also do just find the divisor and the quotient and just plug it in?
So 6 divided by 5 like this?
No.
Okay?
The divisor and the quotient, in this case, would be 4 and 5, and just like multiply them?
4 times 5 is 20. Yes?
Or, just plug them into the table.
Say it again, louder.
You just plug that into the table and it'll be.
Well, if you do 4 times 5, so another way to think about it maybe would be 4 times 5 is 20. Okay? So if you got 6 divided by 4, 4 times 5 is 20, yes? Okay? 20 divided by 6 would be 18, remainder 2, yes? That might not go where I want it to. Divided by 6. No, that's not gonna be what I want. Never mind, sorry. Scratch that. I'd have to look at what you're saying, sorry. Wait, you got another way to explain what you're saying?
So if you take the last 2 numbers, the quotient and the divisor,
Huh?
and you just stick it in on the table and take the, if you take
Yeah.
4 and 5,
Yeah.
you get 6, so.
That works too. Uh-huh. So you're basically saying, if I've got 6 divided by 4, where does 4 and some number here meet up with 6? That would work too, yes. Yeah, that's a good way to think about it. Other ideas? Yes?
So you could also